Puresphere's high-efficiency catalytic oxidizer for reducing carbon emissions equipment. Removal performance is improved by treating and discharging harmful gas twice. Disposing of the gas not removed at the zeolite rotor is feasible at the catalyst rotor. Adsorption process. The VOC's emission generated at the factory is adsorbed by passing through the zeolite rotor, and the VOC's emission not adsorbed is adsorbed by passing through the catalyst rotor, and removal efficiency is improved because it goes through twice adsorption process in the form discharged with only purified gas. The zeolite rotor is economical and contributed to reducing carbon emission due to reducing fuel consumption by concentrating VOC's emission. The synthesis method what Puresphere has developed can maximize efficiency by concentrating 5 to 20 times and removing the VOC's emission that's not absorbed at the zeolite rotor at the catalyst rotor manufactured. Desorption process. By elevating its temperature with using an electric heater and inhaling purified gas passed through the zeolite and catalyst rotor with using desorption fan, it desorbs the VOC's emission concentrated in the zeolite rotor and then discharges. After the low temperature VOC's emission desorbed in the zeolite rotor passes through a heat exchanger and it elevates its temperature at a secondary electric heater, it passes through a catalyst loaded on a catalytic reactor. After the high-temperature purified gas passed through the catalyst passes through the heat exchanger and exchanges heat, it raises energy efficiency. After the purified and medium-temperature gas what exchanges heat passes through the catalyst rotor and removes the VOC's emission concentrated in the catalyst rotor, it's discharged to the outside. The purified gas heated up to 200 degrees Celsius by a primary electric heater desorbs the VOC's emission absorbed in the zeolite rotor. A heat exchanger cuts energy costs by cooling or heating the VOC's emission concentrated. The VOC's emission concentrated is heated up to the temperature of proper catalytic oxidation. By oxidizing the VOC's emission concentrated at a catalyst, it discharges as the purified gas. A heat exchanger cuts energy costs by cooling or heating the VOC's emission concentrated. After the purified gas of 200 degrees Celsius passed through a heat exchanger, flows into a catalyst rotor and desorbs and oxidizes the VOC's emission absorbed and concentrated in a catalyst rotor, it discharges as the purified gas.